Students will be able to find compound interest and find an exponential equation for a story problem. You deposit $3,000 in an account that pays 6% annual interest compounded quarterly. How long will it take for the balance to reach $3,500? So we have $3,500 is equal to, the principal is 3,000, 1 plus 0.06 divided by 4 to the 4t. We're compounding quarterly, so that's why we have 4s here. Let's take 3,500 and divide by 3,000. So 3,500 divided by 3,000. And we want to store that. Let's store that into some variable, alpha a, let's say. So 1.1666, keep on going, is equal to, let's also take 1 plus 0.06 divided by 4. And we have 1.015 raised to the 4t. Now let's take the natural log of both sides. That's equal to 4t times the natural log of 1.015. We can bring the power down in front. And then we just divide by 4 and natural log of that number. So t is equal to, the natural log of really a is what I have in my calculator, but we have 1.1666, keep on going. Divide by 4 times the natural log of 1.015. So let's do natural log of a. We're going to divide that by 4 natural log of 1.015. So 2 and some change. So t is equal to 2.588. And that's going to be how long years? The half-life of a certain radioactive substance is 9 hours. There are 20 grams present initially. When will there be 3.78 grams? And we're going to use the exponential growth model. So we know, let's see, there are 20 grams present. So when we have 10 is equal to, that's half of 20. 20, that's the initial amount. E to the k times 9, that's the half-life. Now this will always be a half when we're calculating half-life. We have e to the 9k. Let's take the natural log. That'll always be the natural log of 1/2. It's equal to the natural log of e to the 9k. Well, natural log and e cancel each other out. We have natural log of 1/2 is equal to 9k. So k is equal to the natural log of 1/2 over 9. That'll always be true. It's always natural log of 1/2 over k. Because it doesn't matter if it's 20 or 10 or 150. If it's half-life, it's going to be half of the initial amount. The only thing that'll vary will be the amount or how long the half-life is. So we found the k. We can actually get this as a decimal. Natural log of 0.5 or half, and we're going to divide by 9. And we can store that in alpha k. There's the k. Now we need to know, when will there be 3.78 grams? 3.78 is equal to 20 e to the negative 0.077 we'll write, but we'll use the whole number times t. So we need 3.78 divided by 20. That's e to the negative 0.077t. We're going to take the natural log of both sides. Natural log of 3.78 divided by 20 is equal to, now when we take the natural log of this side, the e will go away. So negative 0.077t. So t is equal to natural log of 3.78 over 20, and then all of that divided by negative 0.077. We'll use the whole number rather than that rounded answer. We have natural log of 3.78 divided by 20. And then divided by k. So 21. That's equal to 21.632, and that's going to be hours. How long does it take $300 to double if invested at 9% annual interest rate compounded continuously? So that's the PERT. So amount is equal to P e to the RT. So the amount we want to be 600. The initial investment's 300. E to the 0.09 times T. Now we already know the rate. We have everything we need really. 2 is equal to e to the 0.09 t. Take the natural log of both sides. 0.09 t. So natural log of 2 is equal to 0.09 t. So t is equal to, and we just have to take the natural log of 2. Natural log of 2 divided by 0.09. 7.702, and that's going to be years. Let's do a little graphing. E to the x minus 2. Well, if we take e to the 0, that's 1. E to the 1 is 2.718, so almost 3. And then squared will almost be 9. So here's the parent graph for E. And we're going up very quickly. Something like that. And then let's graph 2 to the right. So right 2. 1, 2. And almost 3. 1, 2 here. Now the asymptote did not change. All we did is move 2 to the right. That's it. The domain is negative infinity to infinity. The range is 0 to infinity. And there is an asymptote at y equals 0. Now if we put minus 2 here, that's 2 down. So we'll go off the blue. We have our horizontal asymptote at y equals 0 got moved down 2. So we'll mark that. And this point is down here, and this point is down here. So we go up like that. The domain is negative infinity to infinity. The range now is negative 2 to infinity. And we do have an asymptote at y equals negative 2. Jordan wrote an exponential equation to model the cost of gasoline. He found the average cost per gallon of gasoline for 2 years and used these data for his model. So we will do 1990 as year 0, and we have 1.19. And then we have another point. Well, if the average cost of gasoline increased at an exponential rate, identify the rate of increase. Write an exponential equation to model this situation. So letter A. We have amount is initial amount e to the kt. So the initial amount we'll call 1.19. So n is equal to 1.19 e to the kt. But we have to find k now, but we use the next point. So from 1990 to 2000 would be 10 years, and then another 11 is 21 years. Now in 21 years, the value was the price was $3.91. So we have 1.19 e to the k times 21. So we have 3.91. We're going to divide by 1.19. And let's store that in, let's say, A. I think we have to store it, maybe not. We have 3.2857, keep on going, is equal to e to the k times 21. Now we're going to take the natural log of both sides. And that gets rid of the e, so 21k. So k is equal to the natural log of this number. I didn't really have to store this. Natural log of the answer. We have to divide that by 21. So that's the k. The k is 0.05, let's say 0.0566. So the letter A is N is equal to 1.19 e to the 0.0566 t. Use your model to predict the average cost of a gallon of gasoline in 2015 and 2017. Well, let's put this number into K. So we're going to store alpha K. Average cost in 2015, so that's 21. Another 4 years is 25. N is equal to 1.19 e to the 0.0566 times 25. So 1.19 and then e to the K times 25. So 490. 490, and then N is equal to 1.19 e to the 0.0566 times another 2 years. That's going to be 27 years. 27. And I just need to change that to a 7. So entry, let's back up, make that a 7, and we got it. 549. When will the average cost per gallon of gasoline exceed 7? So when will 1.19 e to the 0.0566 t be greater than 7? So let's take 7, divide by 1.19. We got that value. So e to the 0.0566 t is greater than 5.882. Keep on going. Let's take the natural log of both sides and then divide by K. So natural log of answer. We're going to divide that by K. So 31. 31.281 years. Why might an exponential model not be an accurate representation of average gasoline prices? Gas prices do not increase fast enough for an exponential model to represent the actual price. Exponential growth happens very fast. Oh, if I was there, I'd have you do this as your turn. You know what? I should just give you the answer and then have you guys try this. I'm going to pause the video. Actually, I think when I hand this out to you, the answers will be there, and make an attempt to get these answers.